Okay, 2 pages left. Here we go. Graph and label the following vectors given in rectangular form. Doesn't matter where you draw them. I can just start this here. Whoop, I can't because I'm going to go up 5. I'm going to start this one down here. I'm going to go over 3 and up 5. And so that is a representation of vector A. I'll turn that into an A right there. Positive 3, positive 5. If I do B right here, I can start B. I don't know, I got to sneak it in maybe right there. And that's, whoops, maybe right there. And that's positive 4 and negative 3 up. Can't even squeeze it into my own test, but you get the idea. However you want to represent it, you can draw it on a separate graph. But that's going positive 4, then down 3. So this is B. Add the above vectors, but do not graph. So 3, 5, plus 4, negative 3. I just add the x components, I get 7. Add the y components, I get 2. That's that solution. State the resultant vector also in rectangular form. Have done that. Convert polar vector, which is given as a radius and a degree, into rectangular form. This is going to be 2 times the cosine of 60 degrees, comma, 2 times the sine of 60 degrees. Okay, I happen to have those ratios memorized. The cosine of 60 is just 0.5, so 2 times 0.5 is 1. And the sine of 60 degrees is radical 3 over 2, times 2 is just radical 3, which is about 1.7, we'll go with, approximately like that. Then add vector C to vector B above. That's 4 comma negative 3. If I add that, I get 5 comma negative 1.3, and convert the resultant into rectangular form. Well, if I want to know, oh, there's a bit of a mistake. Yeah, into rectangular form. They're already in rectangular form. There's nothing to convert. That's a typo. Maybe I meant polar. Apologies. In rectangular form. That's the x and y form. Yeah, I think I meant polar. Well, we won't do that now. Alright. We'll do that. Oh no, I think that we will do that now. Let's pretend that says polar, because you might have to do that on the test. Alright, what you would do is you'd say, well, if I'm going to graph this, I'm going over 5 down 1.3. I'm right there. That's that vector. 5, negative 1.3. The radius, r, I'll squeeze that in there. The radius is just going to be 5 squared plus negative 1.3 squared, square rooted. Alright, so I'll grab the calculator, and 25 is 5 squared plus 1.3 squared is 26.69, and then I raise that to the 0.5, I square root it. 5.2, r is approximately equal to 5.2. I need to find that angle theta out, so if that's 5 and that's 1.3, I'm going to do the inverse tangent of 1.3 over 5, and that will give me the angle, the reference angle. So inverse tangent of 1.3 divided by 5, and I get 14.5 degrees, or 14.6 degrees. So theta equals 14.6 degrees. Well, for polar, I go all the way around except for that 14.6 degrees. So my radius, my theta then for that polar coordinate, my final answer will be 5.2, comma, and 360 will be then, minus 14.6 will be 345.4 degrees. Okay, when I've taken away 14.6. That's the answer for this number up above. Triangle has sides of 7, 13, and 18. There's 18. There's 7. There's 13 approximately. You always want to make sure that 7 and 13 add up to more than 18, otherwise you won't get a triangle. solve for all the angles. This is a law of cosines problem. And I'm going to solve for the largest angle first. It's easy to do that. I'll say 18 squared equals 13 squared plus 7 squared minus 2 times 7 times 13 cosine of theta. And now I'm just going to work backwards really quickly. From there, 18 squared is 324. Then 169 is 13 squared plus 49 minus 14 times 13 times the cosine of theta. Make sure that you understand that's all multiplication. And I'm going to sneak it in down here. But 324 minus 169 and also minus 49 is 106. So that gives me 106 is equal to and 14 times 13 is 182 cosine of theta. Well, if I take 106 and divide it by 182, I get 0.58. And that is a negative. By the way, that's a negative. So I'm going to times that by -1 quickly. And then I'm going to do second cosine and plug the answer in there. So I do inverse cosine of that answer up above, and I get an angle of 125.6 degrees. So that's 125.6 degrees. I'm going to then do the law of sines and say the sine of 125.6 degrees over 18 is equal to the sine of, call that A, angle A, over 7. So I'll do sine 125 and divide by 18, and then I'm going to multiply by 7, and I get 0.136. I'm going to do inverse sine of that answer, and I get 18 degrees. So that's 18 degrees, 0.4 degrees. And then I'm going to add that to 125.6, and I'm going to subtract that from 180 to get 35.9 degrees. So that angle there is 35.9 degrees. So there are the three angles of that triangle. Okay, we're good.